Hello, happy people. This is our second video this week for Algebra 2. We talked about exponential growth last time. Today we're going to be talking about an extension of exponential growth, which is compound interest. So the difference is last time we always assumed that everything happened once a year. With compound interest, we can compound any number of times a year. So for compound interest, here is the formula we're going to use. I'm going to pause now so you can pause the video and write this equation down. All right, so remember our growth formula was y equals a times 1 plus r to the x or to the t. Well, we're just going to replace some of those today with different letters. So a, capital A, is going to be the amount of money over time. So that's what our y was. Remember, a last time was our initial amount, lowercase a. Well, this time we're going to call it p, or the principal amount, because that is what a bank would call it, is the principal amount or the original amount of money. R is still going to be a growth rate, and we're still going to change that to a decimal. The only difference is between yesterday and today we now have the number of times it's compounded annually. So it might be compounded biannually or quarterly or once a month. So we're going to have the number of times that happens per year. And t is still the amount of time that passes in years. So here's the example we are going to do. I'm again going to pause so you can write this down, and then we're going to go through both of these questions, and that will be the lesson for the day. All right, so it says we invest $2,000 in an account bearing 4% interest for 5 years. So our first question is, how much will the account be worth if we compound it quarterly? And then we're going to see how long it would take to have $2,500 in the account. So the first question would what would be in the account if we compounded quarterly? So the equation that I just gave you, we're going to use a equals p times 1 plus r over n to the nt. So we're going to use this equation. So we're going to put down everything we know from the question. The question said we invest $2,000, so that's our principal amount. The question also said that our growth rate was 4%, and if I turn that to a decimal, divide by 100, and I get 0.04. And then this question says it's compounded quarterly. So that means the number of times that it's compounded per year. If it's compounded quarterly, there are 4 quarters in a dollar. There are 4 quarters in a football game. So quarterly means it happens 4 times a year. And then the other thing they gave us was the time in years, which is 5 years. So we're going to plug that in as well. So we're just going to plug all these amounts in to find A. So if I do that, I'm going to get 2,000 times 1 plus 0.04 divided by 4 to the 4 times 5 power, which is 2,000. And then 0.04 divided by 4 is 0.01. So I'm going to get 1.01. And 4 times 5 is 20. And that's what I'm going to put in my calculator. And if I do that, I get 2,440.3.8, which again is 2 decimal points because we're talking about money. So the answer to our problem is $2,440.38. So the answer to our first question, what would the account be worth if we compound quarterly, is right there. All right, our second question was how long would it take to have $2,500 in the account? So I'm just going to rewrite our formula. Oops. Our formula was A equals P times the 1 plus R over N to the NT. All right, so this time we still have our principal amount of 2,000. We still have our growth rate of 0.4 or 0.04, sorry. We still have, we know that it's being compounded quarterly or 4 times a year. And we know that our time is going to be the thing we are looking for. So we don't know our time, but we do know our A, and our A this time is 2,500. So I'm going to put that in for A. So I get 2,500 equals our 2,000 times our 1 plus our 0.04 over 4 to the 4t. So that's going to be the equation that we are going to use. So if I simplify that, that is 2,500 equals 2,000 times 1.01 to the 4t. So now this looks like an equation that I made you solve last week when you were solving equations with logs. And that is exactly what we're going to do because we're trying to solve for an exponent. All right, so we have 2,500 equals 2,000 times 1.01 to the 4t. Remember to use logs, we have to get our power alone, and our power is our 1.01 to the 4t, so we want to get that alone. So in order to get that alone, I'm going to divide both sides by 2,000. And when I divide both sides by 2,000, on this side I get 1.25. On the other side, my 2,000s cancel out, and I'm just left with 1.01 to the 4t. So I don't want that exponent up there anymore, and the one kind of function that allows us to bring a power down is a log function. So we are going to use the log function. We're going to take the log of both sides. So I'm going to have the log of 1.25 equals the log of 1.01 to the 4t. So now I can bring that power down. So I'll have the log of 1.25 equals 4t times the log of 1.01. All right, so we have the log of 1.25 equals 4t log of 1.1. So get our t alone. We're multiplying by 4 and the log of 1.01. So I can divide that on both sides. So I'll get the log of 1.25 divided by 4 logs of 1.01 is going to equal my t. So when I put that in my calculator, I'm going to make sure to put the bottom in parentheses so that the order of operations is followed. We want to take the log of 1.25 and divide it by that whole thing, not just take the log of 1.25, divide it by 4, and then multiply it by the log of 1.01. We want log of 1.25 divided by this whole thing. And if you put that in your calculator, you will get 5.61. Which would not cause an extraneous solution for any reason because t is the power. So our answer is 5.61 years. All right. So as you can see, using interest and growth is an extension of our log chapter because we can use logs to solve for time. So 2 things we're adding today, number of times something is compounded, and you are probably going to have to solve for t using logs. All right, so I hope you are all happy, I hope you are all healthy, and I hope you all have a great day.